Okay, Math 10C, factoring polynomial expressions, lesson number 10 practice test. These videos are for study purposes only. I try my best to minimize my mistakes, but they will happen. I will try to show and explain most of my steps, and the videos might be long, but hopefully they will be helpful to you. Okay, let's get started. One of the factors is, so when you observe this, we always see 9, 6, 3. 9, 6, 3 have a common factor of 3. And then x to the power of 4, 3, and 2 have a common factor of x squared. So what is left? 3x squared minus 2x plus 1. So what is one common factor? 3x squared plus 2x plus 1. D. When fully factored, the expression this is written. So we here have 3x and here have 2x. How many number of x do we have in common? X squared, 2x's. Y squared and y cubed, how many y's are in common? 2 y's. What is left? We are left with 1x. Here we have a subtraction sign and we are left with 1y. So the final answer is going to be C. Now response 1, the greatest common factor. When the greatest common factor is removed from the binomial, the binomial can be written in this form. The value of a minus b minus c is. So 75 and 50 have a common factor of 25. X and x squared has a common factor of x. What is left? 3 minus 2x. So a is equal to 25, b is equal to 3, and c is equal to negative 2. So a minus b minus c, 25 minus 3 minus negative 2 is equal to 22 plus 2, which is equal to 24. 3. The expression 3ab squared minus 6a cubed b plus 3ab when fully factored is written. 3, 6, 3. Common factor is 3. A cubed a, common factor is a. B squared, b, common factor is b. Now what is left? We have b minus 2a squared plus 1. So plus 1, sorry. I'm pretty sure I factored this right, but now these are answers, so 3 must be D. Okay, the algebra tiles represents a factor form of, so this big piece is a long one, so that's x. And these are 2 ones, and black means positive. Here we also have a long piece that represents x. Here we have 4 long pieces, or 4 square pieces, each represents 1. So we have x plus 2 on the top times x plus 4 on the side. The answer is C. 5, one of the factor is, so a diamond puzzle, negative 24, 10, or negative 10. We have well, 4 times 6, that's a tricky one. They don't want, it's not 4 times 6, instead it's going to be negative 12 and positive 2. So we have a minus 12 times a plus 2. 5 is D. 6. The factor form of the algebraic expression represented by the algebra tiles are. Okay, so this is negative x squared, this is negative x, and then these are plus 6. Plus 12. There we go. So we have negative x squared minus x plus 12. I don't like it factored this way, so let's take out a common factor of negative 1. So we get x squared plus x minus 12, which can be factored. Negative 12 goes on top, 1 goes on bottom. We get 4 and 3, negative 3. So I get negative x minus 4, x plus 4 times x minus 3. So now because we have to, well, obviously D is not right because it's not the factored form. So I have to x minus 3. So if I factor in the negative 1, then I have x plus 4 times, so negative times negative is positive, so positive 3 minus x. So which one of this look like this? It looks like the answer is A. So 6 is A. Okay, use the following information to answer the next question. Rectangle ABCD has been subdivided into 4 regions. The area of the 2 indicated regions are is 144, and the other 2 regions, the combined area of these 2 are 25a. So what we want is a squared plus 25a plus 144. They want us to factor this, so 144, 25. What is on each side? 12 times 12 is 144. Doesn't work. 9 times 16, I think. Yeah, so 9 and 16. So that means one side, so this is a plus 9 times a plus 16. So one side is a plus 9, the other side is a plus 16. What is the perimeter of a rectangle? Add these two sides up and multiply by 2. So a plus 16 plus a plus 9, sorry, plus a plus 9, and then times 2. So 2a plus 25 times 2, which is equal to 4a plus 50. 7 is C. 8. Which of the following trinomials is b plus 3 not a factor? Well, it does say trinomial, so I am assuming these two are trinomials, but we should still take a look. So the first one is common factor b times b plus 3. Okay, nothing to see there. Second one, common factor b times b squared minus 9. Now we have a difference of squares, which is equal to b times difference of squares, b plus 3 times b minus 3. So this one checks out. Okay, this one, 15, and so negative 15 and 2. What times what is negative 15 and adds to 2? 3 and 5. Which one is negative? Negative 3. So this is b minus 3 times b plus 5. Right? Okay, so there is no b plus 3, so C is very likely the answer. And then b squared minus 6b minus 27, negative 27 goes on top, negative 6 on both on bottom. What goes on left and right is 9 and 3, which one is negative? 9. So we have b plus 3 times b minus 9. So which one doesn't have a negative? Doesn't have a b plus 3? Well, this one b plus 3, this one b plus 3, this one b plus 3. The only thing that's missing is C. So 8 is C. 9. The expression blah 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 px cannot be factored over the integers if p has a value. Okay, so let's do 4 diamond puzzles. 20 goes on top. Which one doesn't have a diamond puzzle? So negative 9, negative 12, 21, 20. So 21 is pretty straightforward, it's 21. What times what is 20 and adds to negative 12? This one is nice, it's negative 4 and negative 5. This one is negative 10 and negative 2. This one doesn't have a solution, so it's D. 10. The largest W for this can be factored over the integer. So I want 48 to be on the top. This is negative W. And what I want is I want the left number and the right number. So one of them is going, well, both of them are going to be negative, but I want one of them to be as small as it can be, and the other one is as big as it can be. So one of them smallest is 48, and the biggest is 1, and they add up to negative 49. So W is equal to 49. So typically we think about it, right? So if the middles are 6 and 8, then negative 6 plus negative 8, sorry, negative 6, yeah, plus negative 8 is equal to negative 14. And which is obviously not as big, because if the two numbers on left and right are closer together, that means the bottom number is going to be smaller. How to make the bottom number big? Well, the left hand, so one number is 1, the other number is your original number, so that makes the number big. Okay, 10. While the factors of 7a squared minus 28a to the power of 4 is, so common factor, 7a squared. 7a squared times 1 minus 28 divided by 7 is 4. A to the power of 4 divided by a squared is a squared. Okay, now we have a difference of squares. 7a squared times 1 plus 2a times 1 minus 2a. Answer is A. 11. Which of the following is a factor of this whole thing? Okay, so we have to do decomp. AC goes on the top, negative 6. B goes on the bottom, negative 1. What times what is negative 6 and adds to negative 1? Negative 3 and positive 2. Decomp, we get 6y squared minus 3y plus 2 minus 1 plus 2y minus 1. Group. Common factor, 3y times 2y minus 1 plus 1 times 2y minus 1. 3y plus 1 times 2y minus 1. 3 plus 1 times 2y minus 1. 11 is D. 12, or numerical response 3. This can be factored by grouping into product of two binomials. If one of these binomials is x minus 5, then what is the value of c? So if we group the first two, then what is the common factor? It is 2x times x minus 5. So that means the second two, negative 3x plus c, must be something times x minus 5. Okay, so box times x is equal to negative 3x. So I think this is pretty obvious, where the box would be negative 3. And what is negative 3 times negative 5? It is equal to 15. And that's what C is. Okay, in each of the questions, 4 responses are given, blah, blah, blah. Okay, this is just a factor question. 2 times negative 15, so we use decomp, negative 30, negative 7. What times what is negative 30 and adds to 7? We have 10 and 7. Which one is negative? Or, oops, 10 and 3. 10 is negative, so we have decomp 2t squared minus 10t plus 3t minus 15. Group 2t times t minus 5 plus 3 times t minus 5. T minus 5 times 2t plus 3. T minus 5 times 2t plus 3. 2 and 4 is the answer, so this is C. Okay, 13. X squared plus 25y squared has a factor of so this is a sum of squares. Sum of squares cannot be factored unless there is some other kind of factor between x squared and 25y squared, which there isn't any. So because it cannot be factored, it is D. Oh yeah, and there's nothing common between x squared and 25y squared. 14. The trinomial can be factored over the integer if. Okay, so we just see which one works, I guess. So if a is equal to 1, c is equal to 36, well, So if diamond puzzle works, then that means it works. So A is C equal to 36, B is equal to negative 12. Okay, what times what is 36 and adds to negative 12? 6 and negative 6 and 6. So this one works. Second one, so it is still the same. It is now, so this is technically, what's it called? It is technically decomp. So A times C and 12 on the bottom. So it's still negative 6 and 6. So this can be factored. 3. I have negative 36 and, I have negative 36 and negative 12. What times what is equal to negative 36 and adds to 12? 18 times 2 doesn't work. 3 and 12 doesn't work, so there's nothing. Last one, again, a decomposition question in disguise, negative 36 and negative 12. Well, it's the exact same thing, so there's no solutions. So the only ones are 1 and 2. If I have 1 and 2, I pick A. 4. If 4a squared plus 44a plus c is a perfect square trinomial, then the value of c must be. So 4a squared is 2a all squared, right? And the middle term must be 2 times 2a, which is the first term squared, times something else. And then by something else, I'll just put a square here. And then the last term is this square thing squared. So we know 2 times 2a times squared is equal to 44a. So this is 4a, right? 4a times squared is equal to 44a. So observation, where divide both sides by 4a, we get this thing is equal to 11. Therefore, 11 squared is equal to 121, which is the last term. So C must be 121. When fully factored, this is written as, so this is difference of squares. This is 4a squared all squared. So 4a squared plus 1 times 4a squared minus 1. So now we have another difference of squares. This thing is 2a all squared. So we have 4a squared plus 1 times 2a plus 1 times 2a minus 1. So what is this? It is D. 5. This algebraic expression has been partially factored. So just by observation, 7 times a is equal to negative 14. So a is equal to 2. 2 times b is equal to negative 18. Therefore, b is equal to 3. Yeah. And then, so c is the leading coefficient, so c must equal to 5. And what's d? Well, so c times d squared is equal to 80. So c is 5, so divide both sides by 5, we get d squared is equal to, what's 80 divided by 5? 16. So therefore, d is equal to 4. 2, 3, 5, 4. 2, 3, 5, 4. I probably went over that one a bit too quick, but then getting tired and I want lots of stuff done. So why do I know this? So because terms without the power of x must multiply to form terms without power of x. So I know negative 7 times a is equal to negative 14. So therefore, they a is equal to 2. Same thing here. I know 2 times negative b times b, it is equal to negative 18. So this negative 18 results from 2 times negative b times b. Okay? And then if we kind of expand this, I get cx squared plus, minus 2cdx minus, or plus cd squared. Okay? So the c must be the 5, and then c times d squared is equal to 80, and I know c is 5 already. Divide both sides by 5. I get d squared is equal to 16, therefore d is equal to 4. So a pretty nice question. Just pretty nice question. Just there's some trick involved if you want to do it a little bit quicker. That's basically it. Okay, written response. Students are investigating polynomials of the form ax squared plus bx plus c, where a, b, c are integers. State a polynomial which can be factored over integers. They just want a b value, right? So I have 16. Diamond puzzle. I want something on the bottom, right? Does it matter what? No. So I just do 4 times 4 is equal to 16. And 4 times 4 is equal to 16, so the bottom will be 8. So x squared plus 8x plus 16. Say a polynomial which cannot be factored over the integers. Explain why is it not possible. So now we have to find someone that cannot be factored. So typically, the only time, so the bottom number must be the bottom number are usually smaller than the top number unless it is one bigger. So if I say the bottom number is 100, there's no way that is able to be factored. There's also, you can also try some smaller numbers like 1, because 16 times 16, there's no way 1 works. So if you find any number on the bottom and you can't do a diamond puzzle, that means it cannot be factored. So x squared plus x plus 16, or x squared plus 100, 1000x plus 16. Because what times what is 16 adds to 1000? Nothing. Why is it not possible? Well, diamond puzzle doesn't work. Okay, if a is equal to 1, c equal to 16, determine how many polynomials of this type can you factor over integers. So now, so 16, I want to see what bottom number can there be, right? So if the top number is 16, what can my left and right number be? My left and right number can be 1 and 16. My left and right number can be 2 and 8. My left and right number can be 4 and 4. And for each of these, so if I switch the numbers around, then it doesn't really change. But it could also be negative. So -1, -16, -2, -8, and then -4 and -4. So there are 6 different ones that can be factored over the integers. And what are the b values? The b values are 17, -17, 10, -10, 8, and -8. So there are the choices. So we have 6 different b values that can be factored. Okay, state a polynomial in the form of a squared plus bx plus c, which can be factored over integers and have a plus b plus c is 20. So as long as diamond puzzle works, this will have a solution. So okay, so let's say if a is equal to 1, then 20 can make anything work. 18 and 2. Don't think that works. 17, 3, 16, 4, 15, 5, 15, 6, 13, 7, 18, 12, and come on. 12 and 7, does it work? Yeah, it does. So 3 and 4, right? So I can have x squared. 1x squared plus 7x plus 12. That can be factored. This is equal to x plus 3 times x plus 4. Yeah, just one example. I'm sure there are others. I'm just looking at this this thing. So apparently 9 and 10 works too. So I have 10 and 1. Sorry, 9 and 1. So I get 1x squared plus 10x plus 9, which is equal to x plus 9 times x plus 1. Okay, the trinomial ax squared plus bx plus c cannot be factored over integers using a method of decomposition, explaining why a, b, and c cannot all be odd integers. Okay, so usually we say ac is on top, b is on the bottom, right? So if a, b, c are all odd, that means ac, so that means the top must be odd, and the bottom must also be odd, okay? So odd times odd is odd. So if two numbers multiplies to equal to the top number, that means the left one and the right one must also be odd. Now because if the left one and the right one are odd, then the bottom one, they add up, it must be even. So there is a contradiction there. Let's look at it again. So if we assume A, B, C are all odd, so A times C must be odd on the top, and B must also be odd on the bottom. Now, for two numbers to multiply to an odd number on the top, the only case that is possible if the left number and the right number are all odd. But if the left number and the right number are odd, that means they add up to an even number. So we have a contradiction. Therefore, A, B, C cannot be all odd. I'm not going to write it down. It seems like too much work. Okay, now that is it for factoring polynomial expressions level 10 or lesson 10. Hopefully you learned something. Goodbye.